Hi, welcome to our monthly community stream for September. It's been a very busy month. The first thing I want to highlight is that we had a really wonderful conference at the beginning of the month called WASMCon that was from the Linux Foundation, and we had our own co-located event. Our agenda today, we're going to run through a few updates on that. I have the WASMCon playlist up here as a QR code in the top left. I totally recommend checking it out. I'm going to drop I'll drop the link here in the chat. There were so many great talks from many different folks across the Bytecode Alliance, and I didn't see a bad one. So I totally recommend watching the full playlist. Now, I did watch it on 2x, I will say. It's a lot of content to consume. And then after WASMCon, we had a co-located event called Componentize the World. During that event, we were looking to squash bugs, find bugs, and generally increase stability and knowledge across the ecosystem that we've been building within the Bytecode Alliance. Probably some of my favorite outcomes include a new SIG documentation. Let's jump over to that one, actually. So within SIG documentation, we've been talking about lots of different types of documentation that we need. And so this is a place for folks that are enthusiastic about documentation to join. So if that's something you're interested in, I totally recommend checking it out. I highlighted this last time, but let me jump over to the component docs repo. This is where a lot of the work is happening right now in terms of documentation. And there is a book that you can jump to here that is published at this location. I'm going to drop this link in the chat too. I think it's really helpful. It's had a ton of iteration over the past couple of weeks, and that's been really wonderful to have. I think it's a really good way to onboard. Back to our agenda, which if you're not familiar, you can jump to the meetings repo and go to the community stream. And so other things that have happened that I think are worth checking out is that we've got language exercises that Alex created. And in there, he also has solutions doing so with Rust. We've got lots of iteration in the C++ space, and Joel posted his Python answers as well. So lots of great resources to get started. And if you have any questions, definitely jump over to our Zulip. Let me post a QR to that. So as a reminder, this is a live stream. So if you have any questions, post them in the YouTube chat or jump over to our community stream in Zulip, and we'll try to answer those live with you today. I have one other project update that I'm going to run through, and then we're going to have other recognized contributors talk about some of their projects. So the next thing is syntax highlighting for WIT. That's had some pretty cool updates here lately. I am going to jump to this pull request from Dan Goman, where he's been adding, there are many different pull requests that look just like this one, but where we've been adding this, one of the last features to the component model, which is resources. And what's really cool is that I can jump into one of these WIT files, like let's view the rendered file. And I have syntax highlighting for resources and all of the latest WIT syntax. So I'm rendering this right now from GitHub. So the way that this works is that their GitHub Markdown rendering uses a tool called Linguist. Linguist is pointing to our tool called VS Code WIT. Let me jump to that here. So that's this project here within the Bytecode Alliance. Eduardo Rodriguez has been working on this diligently. There's been several other contributors now. Dave Barker has also jumped in and has been pushing up a lot of fixes. And so this has been a really nice thing to have. I also want to highlight that there is also a VS Code plugin. So now you can jump over and install this yourself. And so you can get rendering something like, let's see, I'll share another window. Same PR from Dan here. And you can see that it looks super nice inside my IDE. So I'm really happy to have that. And so thank you, Eduardo. So next up on our agenda is to talk about Danny's going to talk about the work that he's been doing as part of SIG registry and also package management and work. Danny, it's really great to have you. How are you?
I'm doing well. It's great to be here.
You gave a really amazing talk. Let me plop up a QR code for that. Danny's talk is in the top left corner here. And so when you gave that talk, you went through a lot of different types of package management and how this current work relates. Do you mind giving a little bit of an introduction to people who maybe haven't seen that talk?
Yeah, totally. So basically, I am part of the Bytecode Alliance registry SIG, and we're focused on package management for WebAssembly and specifically the component model. And so the main project that we're working on is Warg, which is actually a protocol that we expect there to be multiple implementations of, and actually like there are two that I'm aware of that are like there's like the reference implementation, and then there's like another implementation that some of us have been working on that is more like aimed at scalability rather than like being a reference. But yeah, essentially implementations would be an implementation of a registry that you can then use to publish packages to or WebAssembly components to.
Yeah. So basically, we want a registry that is components native, that understands what is inside a component and all the interface definitions that make up that component. I understand that you might actually have a demo of this available. Is that something you're willing to show off here live on stage?
Yeah, definitely. Give me a moment and I can share my screen. And so also something else that I'll mention as I'm going into the demo too is that a lot of the stuff that we've been doing for Warg recently, we're like getting to a point where we'd like to kind of guarantee some level of stability. Specifically for people who are like making contributions in like the WASI workspace. Preview 2 is like looking at being finalized in the next couple of months. And so what we've decided actually is that we're going to do a version bump of like the Warg project to 0.2.0, which is essentially, hey, we're going to be at a point where we want the contributors to be able to lean on the registry for their development. So that's something that we're really excited about. And right now I'll show off some of the stuff that I showed off at WasmCon, where basically we are publishing packages and like working with transitive dependencies. And I'll go ahead and start. So basically, first I'm going to show off what it looks like when we're actually like working with WAT components, because I think it's a little bit easier to understand transitive dependencies when we do this. And then we'll actually look at like several different guest languages working together as dependencies of like one WASM component.
Hey, Danny, would you mind increasing the font size?
Totally. How is that?
Let's see. Yeah. Can you go one more? And I think it'll be perfect. Perfect. Yeah, awesome. Thank you. And one more question, sorry. Is 0.2.0, does that have a goal date set?
Yes, I meant to say that. That is October 20th. So the idea being that should be ahead of when like Preview 2 is officially done. And so what we'd like is to be like stable ahead of the Preview 2 release, so that way people can rely on it as that's actually happening. Yeah.
Awesome. Thank you. Okay, I'm going to butt out of your demo.
Cool. So anyways, right here, I'm not going to go like super into detail of like explaining the WAT like source code line by line, but this is a function essentially that just like adds two numbers together. And what we can do is we can actually do an initialization of this component, which is going to let the registry know that this package exists. And then we can do a actual release of this. So here we're releasing version 1.0. Then what I've done is I've got a couple of other components here that rely on that. So here we're importing that package that I just published to the registry, and we're using it to define a new function that just adds 1 to a single input. So we can do an initialization of that package as well. and then a publish of version 1.0. And then we also have 5, which basically does the exact same thing, only rather than creating a function that adds 1 to its input, here we're adding 5 to its input. So we can do initialization of foo5. And then we can release version 1 of foo5. And then finally, at the top of this dependency tree, we're going to have another function, another WebAssembly component that imports our increment function and imports our 5 function, each of which import our add function. And so we can go ahead and do an initialization of that. And what this one does is it basically, given 2 inputs, it's going to increment the first one and add 5 to the next one, and then it's going to add those 2 together. And so really what that's going to do is, given 2 inputs, it's going to add those 2 numbers together and then add 6 to the total. So we can go ahead and do a release of foo meet. And let's do an update. And let's check out the dependency tree for this. So if we do this, we actually see that we have foo meet as a package that's at the top, which depends on foo inc and foo5. And each of those depend on foo add, and those are at version 1.0. And actually over here, we can see that this folder is kind of like similar to a node modules in JavaScript, where we like have all of the binaries that I published. So I could actually like do this, which would be kind of like the equivalent of like blowing away my node modules. And when I run this dependencies command, it's actually going and it's fetching all of those WebAssembly binaries from the registry for me. And so now what we can do is we can actually do like a lock. So I'm going to run lock. And let's print that out. And when I do that, our locked component is actually kind of interesting conceptually, because people are accustomed to seeing like a lock file, but this is more of a semantic lock file. And what we see is right now, like most runtimes that exist that support the component model don't actually they're not registry aware. So like right now, the definitions of like these components don't exist inside of this file, but we do think that like there will probably be registry aware runtimes in the future where actually this file itself would be executable. But what we do see here is that we're actually importing each component with like a verifiable integrity SHA for that version of that component. So we have add, which came in at 1.0. We have increment, which came in at 1.0. We have 5, which came in at 1.0. And we have meet, which came in at 1.0. And then we actually instantiate each of those components in this lock file. And if we had like different versions of different things, then we could see like multiple instantiations. But right here, the first thing that was imported was add. So we're instantiating the add component here. And then that's being fed as an instantiation argument to inc right here, as well as to 5. And then when we instantiate our meet function, we use both the increment and the 5. And I understand that we have a question on YouTube. Is the version range specifiers the same as node semantic version range specifiers? So we basically, right now, we're only supporting like major minor patch, and you can do like a greater than or equal to and a less than or equal to. We don't have like carets or tildes yet. And also, I guess I should mention that even this like locked and unlocked syntax right now hasn't been merged into the main branch yet. So like this, what I'm showing right now is like should be stabilized by the 0.2.0 October 20-ish like date. But right now, like this, you would have to like pull down a feature branch in order to interact with some of the syntax that's used for some of the stuff that I'm showing off right now. But yeah, so because the runtime that we're going to be using, which we're going to be executing these components using Jco, is not registry aware, we actually need another step, which is bundling. So if we run bundle on this component, and we can actually print the result of the bundled component and look at that. This is basically the exact same thing as the locked component that we had. The only difference being that every time that there was an import, instead of there being an import, we're actually taking the content of that actual component and putting it into this large bundled WebAssembly component. And then we can use Jco, which basically is going to make JavaScript bindings for us that enable us to execute all of this WASM that has been bundled together. So I'll do Jco. And then up here, that'll actually generate JavaScript that we're able to execute that knows about all of the function composition that happens in our large bundled WebAssembly component. And then if we look at index.js, where I'm actually doing an import of the function that we have that is exported from the WebAssembly, we can do index.js. And we can see that we're feeding in 2 and we're feeding in 3. And we added 1 to one of them and 5 to the other. And 2 plus 3 plus 6 is 11, which is being printed out down here. So we actually have transitive WebAssembly dependencies that are being brought together in order to, have this big thing. The interesting thing is actually when we're not using WebAssembly as our components, that was handwritten, but we're actually like writing languages that we're familiar with. So I'll show a couple of different ways that you can go about generating components in a few different languages. And then we'll look at what it looks like to actually compose each of these components that were implemented in different languages together into like one large piece of functionality. And so each of these languages have like kind of different levels of component model support. And so it's kind of interesting to compare all of them with each other. The first one that I'll point out is this JavaScript example. So this is using a project called Componentize, which is primarily maintained by Guy Bedford. And it is, out of all the languages that we're going to use, the only like dynamic language. And because of that, you actually aren't even targeting the WebAssembly component model specifically with the JavaScript. It's actually using like an embedded SpiderMonkey JavaScript engine. And what we see is that really the only 2 things that you need are to have like a WIT file, which kind of specifies in terms of the component model, the data structures that are used in the function that is exported. So here in JavaScript, I have a function called leet, inspired by like LeetCode, where it's basically replacing E's with the number 3 and O's with the number 0. And so it takes a string as an argument and has a string as an output. And so you need to have a WIT file and just a JavaScript file. And what we'll see with the JavaScript is that compared to our other languages, this is actually just JavaScript. Like our other ones, we kind of not lose. And with Rust, there's like a little bit of like extra syntax around in order to make it so that you can compile to the component model. And then with Zig, which we'll also use, there's a little bit more. But with the JavaScript, you're pretty much just writing exactly JavaScript as you're accustomed to writing JavaScript, and the fact that you want to make a component out of it doesn't really matter. So you can just run node componentize here, and then you end up with a component right here, and that's our JavaScript use case. We also have this one, which is a function that does upcasing. So here in Rust, I'm going to use a tool called Cargo Component, which is primarily maintained by Peter Hune. And so here's what I was talking about was we end up, when we use Cargo Component, we have like this macro right here, which does bindings generation for us. And we have this guest trait that is exposed, which anybody who's writing Rust is probably accustomed to interacting with traits, but this is a trait that you actually do have to implement in order for things to work. So again, we have our WIT file over here, which is necessary for generating WebAssembly components. But inside of it, you basically implement the functions that you say are going to be exposed from your WebAssembly component. So here for this upcasing, we do have an input string and an output string. So we can just run, and if we wanted to see what these bindings look like, you can actually do a cargo expand. And it'll just take a little bit. And here we actually like see what the bindings are that are generated in order for us to be able to interact with the WebAssembly component model. But yeah, you can do cargo component build. And then you end up with a WebAssembly component down here that upcases an input for you. And then finally, I'd like to point out Zig, which is kind of interesting because there isn't like bind gen tooling that exists for Zig, but so long as the code that you're writing is compliant with the canonical ABI, you can write your code essentially a little bit less idiomatically and still end up targeting the component model. So I'd like to, I guess, kind of showcase what's interesting here is that there's tooling that exists that takes core WebAssembly and WIT files and creates components out of them, which is like fairly robust. The tooling is not really aware of Zig at all. It's only aware of the fact that there are core WASM modules and WIT files. And because Zig is able to compile to canonical ABI compliant core WASM, we're actually able to just generate components from the output of our Zig compilation. So here we do, as a result of having this stuff, have to like expose an allocator ourselves and this like reallocation function. But yeah, we're still totally able to generate WebAssembly components this way. So I'll show, I actually like have the commands there already. If we do a Zig build, that is how we go about generating our Zig core WASM module. And then we again have a WIT file over here. And so we basically just have to do an embed of our WIT into our core WASM. And then we do a new, and that basically gives us our final Zig component. And so what this Zig function does is it actually just concatenates two strings together. So given one input and another input, bring those two together. So now the interesting thing that we see all of these different ways that you could actually go about generating a WebAssembly component is we can actually depend on each of these, even though they were implemented in different guest languages, and then compose all of their functionality together, which is pretty cool because usually you're restricted to one language when you're working with a dependencies in a package manager. So I've ahead of time brought the outputs of each of those over here. So we have this concat, which was implemented in Zig, and we have leet, which was implemented in JavaScript, and we have upper, which was implemented in Rust. And then finally, I have stringy, which is basically just importing each of those. So we can see that we are importing concat here and importing upper here and importing leet here. And then we're just going to compose all those together. So let's go ahead and initialize each of those and publish each of those to the registry. So first, let's do init foo. Let's see, I did JavaScript first. So this is initializing, making the registry aware that it exists. Then we can do our 1.0 of the leet JavaScript function. And then we can do an init of let's do the Rust one next. And now let's do the Zig concatenation function. And then finally, let's do the stringy, which brings them all together. And update. And cool. So if we do this, we see that we have stringy, which was published at 1.0, and it depends on concat and upper and leet. And then we can do a lock, which is this. And we can print this out. And here, because we are working with guest languages, we'll actually, in our locked file, see all of these like WASI imports, which, each of the guest languages relies on WASI for being able to like execute outside of the browser. But after all of our WASI imports, we see that we bring in concat with this verifiable SHA at 1.0. And then these are a little bit large because of the WASI interfaces, but we have upper here, and then we also have leet. So given that, we can go and we can do our bundle, which is actually going to inline all of these definitions instead of just showing them as import statements. Bundle foo stringy, and then we can do jco. And if we go to our JavaScript and we expect, rather than adding all these numbers together, we have this, we can do node index.js. And so, yeah, this is the cool, exciting final thing. We are replacing our vowels with numbers, which was done in JavaScript. We are upcasing everything, which was implemented in Rust. And then we are concatenating two strings together. And that logic was implemented in Zig. And we're able to compose all of those things together out of things that were installed from the word registry, which is pretty cool and pretty exciting. So given that, that's basically most of the demo. I'm not sure if there are questions at all about any of the stuff that I showed off, but yeah, there's also like a lot going on here, I know. So I'm like happy to go into any of the details that might be a little bit confusing, but yeah.
Thank you, Danny. That was awesome. So good. I put up the big old QR code for come on in and ask us some questions because you went through a lot. There's a lot of component tooling in the ecosystem, and the thing that glues it all together that makes it really awesome is the registry, which you showed off. One thing I wanted to add is that what you were doing with Zig is not necessarily super specific to Zig. Basically, any language that targets WebAssembly, you can make it do what essentially you did without it actually supporting the component model, which I think is really huge for our story of bringing things forward. And if folks are interested in adding their language, we have SIG Guest Language, which is another special interest group that we have in the Bytecode Alliance, where folks have been getting together and talking about, a lot of the aspects of both having their language target WebAssembly, how to create a guest language within WASM, and then a lot of the tooling that goes into it. And we just spun up .NET as a new working group this month. Go's met a few times here lately. And, somebody like Danny that's passionate about Zig, totally another great place to have that. We were talking about it a little bit before we kick things off. And let's see if I see any more questions coming through. People appreciated your demo, Danny. That's awesome. I did too. I think it's really good. Let's see. Are there good places for people to contribute if they're interested, and where to go?
Yeah, definitely. So there's a GitHub repo under the Bytecode Alliance that is just called Registry, and that is where most of the Warg development actually happens. And then yeah, there's also like a Warg stream where people talk about Warg development in the Bytecode Alliance as well. So those are both great places, and we meet fairly regularly. So I think there's details about the meetings that you can find in the repo, or if you just ask us on Zulip, we're always happy to extend an invitation to a potential contributor.
Cool. So I think important things for folks to know. There's going to be a release for stability so that folks can start building on things so that we can kind of have a foundation for Preview 2 and iterate on top of that. And that is, the goal date is October 20th, and you're calling that 2.0 for the registry. There's the Zulip stream. I put up the QR code for that. That's where a lot of folks talk. And there are like 3 meetings ish. There's developer drop-ins, and there's the regular SIG meeting, which I believe is on a weekly cadence. And if folks ever have a curious about the meetings that we have, I'm going to drop in one more meeting link. It looks like we have another question here. Will there be a concept like peer dependencies? Like in my app, I want all my JavaScript components to link against the same SpiderMonkey version. That's a great question.
It is a great question. I think we're not quite there yet. We basically kind of just started doing some of the Semver stuff. So like as of right now, you can version bump for the first time like a week ago. So I'm sure that, and kind of the point of the 0.2.0 is like, things are going to be available for core contributors, but we're still going to be figuring out quite a bit of, what is actually happening as people are, specifying dependencies and, what happens when you encounter a circular dependency and stuff. We're kind of imagining that that'll get hammered out as people use it post 0.2.0 release.
And there are other parts of this too, parts of this puzzle, beyond just how the registry would handle peer dependencies. There's also the specification level within the component model. Right now, there is shared nothing linking that's been implemented. So you take two components and they don't know anything about each other. So they're not necessarily sharing some of their internal logic, like their memory or functions. There's also shared everything linking, which is actually how the Python component tooling works, where there are many different WASM modules basically all inside the same component. And this specific use case about, hey, I don't want to pull in SpiderMonkey multiple times. How do I keep from pulling in SpiderMonkey multiple times? The answer is basically that last case that I talked about. And I believe it's outlined in the use cases. I just posted a link to that within the component model repo, where it kind of goes through different types of linking that's available. And this is definitely one of those key things that we want to enable, because not everybody wants to load multiple SpiderMonkeys at the same time. So yes, that's definitely a major story, a user story that we want to support. Are there any other questions coming through? Okay, I don't see any, but Danny, do you mind hanging out? And if we get more, you can pop back in.
Yeah, totally.
Cool. Thank you. I really appreciate it. That was fun.
Yeah, fun to be here. Thanks.
All right. So moving along in our agenda, next up we have Johnny Birch. Let me drop you in. Hi, Johnny. How are you?
Hi, Bailey. How are you doing?
I'm doing great. So Johnny, you work at Intel. This is your first time on the community stream. Do you mind telling us a little bit about yourself?
Sure. So yeah, like you said, I work at Intel. Actually, an engineer and a new manager for the WASM team on the US side. We also have a team working on the PRC side, responsible for projects like WAMR. So yeah, I've been working with WebAssembly mainly in the Bytecode Alliance projects, things like CraneLift and WASM Time for the past few years, and looking forward to continuing to contribute.
Awesome. So today you're going to introduce a new project that you've created called WASM Score. What is it?
Yeah, it sounds exciting, but don't want to oversell it. It's really work in development, just getting started. But a lot of what we do is we want to be able to benchmark performance. And, we have people who come and they say, look, can you tell us, for example, if we move this application from native to WebAssembly, what is that performance going to look like? I think one of the things that when I was first introduced to WebAssembly that I was told is that one of the benefits is near native performance, but no one actually defines what near means, right? Is it 5%, 10%, 50%? And that could be different depending on the type of application. So what I wanted to do was to create a benchmark that would allow you to both kind of seamlessly compare platform performance when executing WebAssembly, but also tell you how efficient you are at doing that. So just looking around, there aren't a lot of tools out there. One of clearly the best one that I saw was SiteGlass, and it's something that frankly was started a while ago. I think engineers at Fastly. So that's something that we try to leverage. But in a nutshell, it's a benchmark that aims to compare platform performance and tell you how you perform relative to native.
Really cool. And so I posted a link to WASM Score in the chat, and I've got the QR code up as well if anybody wants to check it out. And I do ask people to ask questions as you go through. And I think you maybe have it running locally, potentially. Would you be game to show it off?
Well, there's some UI work that needs to be done. There's some
Okay.
user experience work that needs to be done, and so that would translate into a demo. But just to actually, I don't even know how well you can see this screen, but like you said,
I can pull it up, but it kind of looks like maybe the restream video is up. Do you mind minimizing that, and then I'll pop it up?
oh, this right here.
Hey, there we go. All right.
Oops. Okay, so anyway, so this is the repository, and one of the design principles that I said was, it needed to be easy to build, easy to run, and one of the problems that I've had, with software that everyone experiences, you just want to try something, you don't really know what it is. There's just a ton of software out there, and you just want to install it and run it real quick. But unfortunately, there's just install after install after install, and ultimately you end up breaking something that already works on your platform. So for that reason, just wanted to just put this in a container and make it easy to download and run. It's already built. So, and you can run it, you can build it locally, but that's it. So effectively, the command to run is just Docker run, and it will grab it from the Bytecode Alliance repository and just grab this package. And keep in mind, it works for both x86 and Arch64. So if you wanted to do this in the cloud, there with AWS machines, for example, you could do that. So just a quick example, you can see all the commands that I've been trying. But like I said, to download it, you just kind of do that
Hey,
Docker
Johnny,
pull, Docker run. Yeah,
do you mind making your terminal a little bit bigger?
yes,
I'm, getting older, I feel like, and I need things a lot bigger. Thank you. I can
yes,
read that.
ma'am.
Thanks.
Sorry about that. Is that better?
Yeah, that looks really good.
Okay. So anyway, there's nothing to it. I just did a pre-run, trying to get my camera to work before this. So you can just kind of Docker run. You can see the help menu, and the help menu just kind of explains that you can run benchmarks, individual benchmarks, suites, or tests. Like I said, this leverages Cyclass. This Cyclass is doing the execution. This is really just a wrapper around that, but it's more than that in the sense that it's a concept of a single score and also of a kind of efficiency score. So anyway, the concept of a test is that a test gives you a score. So that's where that comes from. Right now, WASM score is the default. It's just kind of a generic test that has kind of this 5 categories: app, core, crypto, AI, and regex. Both AI and regex are empty. The reason for that is not because Cyclass and that benchmark repository doesn't have benchmarks that would fit under that category, but it's because we don't have the native build for those so that we can compare those performance between WASM and native. So anyway, you can see, like I said, you can run individual tests, and I'll just give an example. I just ran this. For example, Fibonacci, and you use this dash in, and it will run kind of the both the WASM and the native for that particular benchmark. While that runs, I'll show you that there is a kind of an entire, it's probably over 100 benchmarks that you can run individually, but not all of those benchmarks have a native component. But you can see folks like Nick and Andrew and myself have been contributing to Cyclass and contributed a lot of these benchmarks. I think Andrew, for example, just recently dumped this entire kind of libsodium suite there. So, yeah. So this is running. Frankly, it's taken a little bit longer than I thought it would, but let's see if this finishes quickly. So there it goes. So it just kind of prints out based on, again, Cyclass. It prints out kind of in this neat little graph the time that it took to compile the code. And frankly, that's for native, that's not something we should watch, really. We should just pay attention to execution. Like I said, there's some work here to do here. But for WebAssembly, that makes a lot more sense. It'll print out the compilation time, the time that it took to instantiate, and then separately the time that it took to do just the execution. And when this runs the WASM score kind of test, hopefully this is still translating properly, but here I have kind of an output that's already occurred. I know the font, actually, I'm not sure how the font is coming across or how to change the font here, but let's see if I can. Uh-oh. So anyway, I'm not sure I can make the font bigger, but ultimately what happens is it runs a suite of benchmarks, and at the end it will print out sort of this score. So you have like a score for the app category of the benchmarks, a score for the core category of the benchmarks, a score for the crypto category of the benchmarks, and also produce an efficiency score, which will basically tell you how well the WASM ran relative to the native. So it's just kind of, if the WASM ran in 1 minute, and if the native ran in 1 minute and the WASM was maybe 20% slower, then you would have an efficiency score of 80%. So, and at the end, we can kind of print this stuff out so it's easy to put in a spreadsheet. And that's pretty much it so far.
That's really useful and really great. So have you had any insights? Have you learned anything from after building the tool?
Well, this is something that I just kind of started locally, and we just pushed it over the wall. So there's a lot of work to be done. But yeah, actually, one of the things that I found to be interesting is I wanted to compare the performance on the different platforms on AWS. So they have these different tiers of platforms, and the performance difference that I got was stark. It was pretty impressive. But another thing between the tiers, but another thing that intrigued me was the fact that certain platforms would have a low WASM score, but a high efficiency score. And digging a little bit deeper into that, one of the things that we saw was that on some of these platforms, the native code was doing advanced optimizations that weren't available for the compiler tools or weren't being used for the compiler tools on the lower skewed platforms. So in essence, the efficiency score was showing you potential opportunities to kind of improve the compilation for the WASM. For example, if it's doing an advanced loop unrolling or something like that, that may be an opportunity to do that as well for the WebAssembly code. So it just points out different types of opportunities, not just showing you how well your platform performs at running standalone WebAssembly.
That's really, I think that's going to be really powerful for folks to find where to spend our efforts, right? Otherwise, we're just kind of going in blind. And you've made it with a really good developer experience on top. So that's really great. So you keep mentioning that there's a lot more to do. Do you want to give a little roundup of some of your goals there?
Like I said, this is just thrown over the wall. Someone downloads this and they may, I don't want people to come away with kind of an unimpressive taste in their mouth, but I do think it's has lots of potential. Basically, we want to improve stability. I haven't done enough study on run-to-run variation. Cyclass has this kind of wonderful knobs built in where you can run so many times and make sure that variation between runs is low. So we want to make sure that it's stable. And also just the user experience. Simply downloading it takes far too long. The Docker file has, far too many layers. So just those types of user experience things. And then secondly, add benchmarks. I mean, I have categories here, and right now they're empty. So we need to add benchmarks either here or to Cyclass that include not only WASM support, but also support for the native engine that works in Cyclass. So I think those are the primary two items. And then just submit ideas, right? This is a community effort. Just submit ideas, say what you don't like, what you do like, and see if we can improve this going forward.
Yeah, and we've got one comment from Justin James that this absolutely aids people in building compelling stories for adoption. Yeah, totally. So once you get something working, now you can have numbers that back it up. I'm really excited about all this work. It sounds like you're open to contributions if folks are interested, and maybe you're
Absolutely.
Docker experts. They can help slim that thing down.
Yeah.
Yeah, great. Well, thank you, Johnny. I really appreciate you showing off your work here, and also working through any technical issues to get on the stream. I know it's interesting for the first time. So, is there anything else that you wanted to highlight about the project, or anything else that's happening within the Bytecode Alliance that that you've been involved in?
Not necessarily. Just just excited to be able to show this and ask folks to contribute to site class or here. Either way will benefit this particular project, but no, not really.
Okay, great. Well, I feel like this was a really good stream, and we can wrap it up here. And for anybody that's joined online, please hop on the Bytecode Alliance Zulip and continue the conversation.